Okay, welcome back to Miss Gola's notes on geometry. Today we're going to be talking about segments and the segment addition postulate. So you're going to need the note paper, just a single paper that looks like this. Okay, and you also are going to need a calculator. So we're going to talk about segments today and specifically measuring segments. So yesterday we learned that a segment is a part of a line. So determining how long that segment is, we're going to have to do some counting. So the distance between 2 points A and B can be written as the length of AB. Or we can just say AB. So over here, if we want to determine the length of segment AB, we would have to count how many units A is away from B. So we have 1, 2, 3, 4. So therefore, AB is 4 units long. Okay? Now, congruent is something we're going to see a lot. Congruent means equal. So we can say equal segments. So if AB is equal to CD, so if segment AB is equal to CD, then the two segments are congruent. This can be written as AB and that little squiggle over that equal sign, CD. So over here in the example, if we count 1, 2, 3, 4, CD should also be 4. So we have 1, 2, 3, 4, and it is. Whoop. Okay. The next thing we're going to talk about is the segment addition postulate. So postulates are just things that, or like rules that we go by. So if A, B, and C are collinear points, which means that they are on the same line, and B is between A and C, then we can say segment AB plus segment C, plus segment BC is equal to segment AC. Okay, so what that is just saying is if we add this segment to this segment, since they have the same point, we can say we can get the whole segment. Okay, so let's try a couple examples with us using that. So if PQ is equal to 9 and QR is equal to 28, we want to find PR. So in this diagram, we're saying PQ is 9 and QR is 28. We'd have to add 9 plus 28 to get the whole distance, which is 37. Okay, now let's read number 2. If QR is 17 and PR is 21, so we're told that this part is 17, but the whole thing is 21, we would have to subtract to figure out what's left. So 21 minus 17 is 4. Moving down here, we are told that EG, the whole thing, is 71. We need to find the value of X. Okay, so if we think, we know EF plus FG is equal to EG. This is the segment addition postulate. EF plus FG is equal to EG. Okay, well, what is EF? EF is 8x minus 17. And we know FG is 5x minus 3. And what is EG? Well, we're told EG is 71. So now we have to solve this for X. We're going to combine like terms. So 8 plus 5 is 13. Negative 7 minus 3 is negative 20. Let me turn on my light. Maybe it'll make it a little bit better. And we have that equal to 71. Okay. Then we have to add. So 3x adding 20 on both sides gets us 91. And 91 divided by 13, X is equal to 7. And that's our answer. Okay, so at any point, if you want to stop the video and complete the problem and then restart it and see what I get. If it matches yours, that's a really good practice. Okay, so let's do TV. So we're told TV is 14x minus 8. This is 9x plus 2, and this is 5. So if we do the same thing, we write a segment addition postulate. TU plus UV is equal to TV. We just plug in what we know. We know TU is 9x plus 2. We know UV is 5. And TV is 14x minus 8. Okay. Add like terms. So we have 9x plus 7 is equal to 14x minus 8. I'm going to subtract 9 over here. So 5x is equal to 15. X is equal to 3. So now what we need to do is we need to find TU here, so we need to plug 3 in. Okay. So 9 times 3 plus 2 is 29. And that's our answer. All right, let's do this one. We know JL is 5x plus 2, JK is 27, and KL is 3x plus 1. Okay, so we know 27 plus 3x minus 1, because we did the addition, we added this side plus this side. It's equal to the whole thing, 5x plus 2. Okay. I'm not going to show all the steps for algebra. So we have 2x, and we have 27. This is 24. X is equal to 12. Now to find JL, you have to plug JL back in. So 5 times 12 plus 2 is equal to 62. A segment addition postulate again, so we have to add CD plus DE is equal to CE. So x plus 3 plus 8x minus 9 is equal to 7x plus 14. Subtract, you get 2x is equal to 10. X is equal to 5. And we're just trying to find x there, so then we're done. Okay? It's x. I'll flip it over. We're told that SK is 3x minus 5, and KY is 2x plus 9, and SY is 3x minus 36. Find the value of each. So this is just the same problems that we did on the front side, just a little bit different. So we can say 13x minus 5 plus 2x plus 9 is equal to 36 minus x. So we can add, we get 15 over here, and we add, we get 16x is equal to 36 plus 5 minus 9 is 32. X is equal to 2. Okay, so now we have x. Now we have to find SK, which is just plugging 2 into here. So 3 times 2 is 36. 36 minus 5 is 21. 2 times 2 is 4, plus 9 is 13. And 36 minus 2 is 34. Oh, sorry. Okay. Now we're going to learn about midpoint of a segment. So if we think about the midpoint, if I asked you what is the halfway point between here and Danville, you're going to think of something that's in the middle. So that's what midpoint is. So midpoint, so the midpoint, sorry, of a segment is a point that divides the segment into two congruent segments. A ray, line, or segment that intersects a segment at its midpoint is said to bisect the segment, and it is called the segment bisector. So in the diagram to the left here, B is the midpoint. It's the midpoint of AC. And line L is the segment bisector of segment AC. Okay, so what that picture is showing here is that you have segment here AC, and this line is cutting it in half. So this line is bisecting this segment into two equal parts, and this is then therefore called the segment bisector. So bisect is going to come up a lot in these problems, or midpoint. Okay, so Q is the midpoint of PR. Find the value of X. So if Q is a midpoint, that means these two segments are the same. So 7x minus 16 is going to be the same value as 4x plus 2. So we set them equal to each other. So we subtract, we get 3x is equal to 18. X is equal to 6. H is the midpoint of GI, so that means that these two segments are the same, so we set them equal. 5x plus 2 is equal to 9x minus 10. So we get 4x is equal to 12, x is equal to 3, but the question is asking us to find GH, so that means we need to plug 3 back in here. 5 times 3 is 15, plus 2 is 17. So 17 is our answer. Number 10, we have R is the midpoint of QS, so that means these two are equal. So 2x plus 16 is equal to 5x minus 17. We get, 3x, and if we add 17 over here, 16 plus 17 is 33. X is equal to 11. We're trying to find QS, so we have to plug in 11 into both of them, or we can plug it into one. So if we plug it into one of them, 2 times 11 plus 16 is 38. And since we know that the two segments are the same, we can times that by 2 to get 76. It would be the same thing if we plugged 11 into both of these. We would also get 38 for this one. And the last problem on this sheet, it says G is the midpoint of FG, and FG is equal to 6y minus 2. So what we need to do is we need to find y here. Okay, so if we did the segment addition postulate and we did this plus this is equal to this, we have x and y in an equation, and that can't happen. So we have to first use the midpoint. So we know 4x plus 3 is equal to 7x minus 12. We know 3x is equal to 15. X is equal to 5. Okay, now once we know that, we need to figure out what the whole distance here is. So if we plug it in, 4 times 5 is 20, plus 3 is 23. So that means both of these segments are 23. So therefore, FH has to equal 46. Okay, so 46 is equal to 6y minus 2. Add 2. 48 is equal to 6y, and therefore y is equal to 8. Y is equal to 8. Okay, so I hope this video helped.